Have you ever asked an AI to find something in your documents and it comes back with, well, something that sounds right but completely misses the point? We're going to look at a new approach that aims to fix that by teaching AI to search less like a machine and a whole lot more like a person. You've totally been there, right? You know the answer is buried somewhere in a huge pile of PDFs, but your AI search just can't seem to connect the dots. It's a super common frustration. And honestly, it points to a fundamental flaw in how most AI systems are reading our files right now. So, what's the fix? Well, it's all about moving beyond just simple keyword or concept matching. It's about teaching our AI models to actually reason about the documents they're exploring. To think, to follow leads, and to really understand the structure of the information. Okay, let's get into it. To really understand why this new approach is such a game changer, we first have to talk about the problem with the current state of the art, a technology called Retrieval Augmented Generation, or as most people call it, RAG. This right here, this gets to the absolute heart of the issue. Most AI search today is all about similarity. You ask about corporate mergers, and it finds text with the words corporate mergers. Simple enough. But what if you need to find something that's logically relevant, like finding an adjusted purchase price that's actually defined in a totally separate document called Exhibit B? Yeah, a simple similarity search is just going to completely miss that. So this is where traditional RAG really falls apart. See, to analyze a document, the system first chops it up into these little chunks. But in doing that, it destroys the context. The relationship between, say, a paragraph on page 2 and a table on page 20 is just gone. And any cross-references, like see Exhibit B, they just become meaningless noise to the AI. It really proves the point. Similarity is not the same thing as relevance. So if that machine-first approach has some serious flaws, what's the alternative? What if we could teach the AI to work more like a human researcher? Methodically digging through a folder of files. Well, that is the core idea behind what's called Agentic File Search. And here's what we're talking about officially. It's an AI agent that explores files on the fly. So instead of relying on some pre-built index of chopped up chunks, it actively scans documents, it reasons about what it's seeing, and this is the crucial part, it follows those cross-references from one file to another, just like you or I would. And it does this using this really clever three-step strategy. First, it does a parallel scan, which is basically a quick preview of all the files to just get the lay of the land. Then it does a deep dive, a full detailed analysis, but only on the most promising documents. But the real magic is step 3, backtrack. If it finds a reference to a document it skipped at first, it's smart enough to go back and read it. That is exactly how it solves that Exhibit B problem we were talking about. Now, what's so interesting here is just how simple the agent's tools are. This isn't some crazy complex system. It's using a basic toolkit, scan folder, preview file, read, grep, that would look totally familiar to any developer on a command line. It's using these fundamental building blocks to do some really sophisticated, human-like research. This all sounds incredibly powerful, right? And it is. But as you might have guessed, trying to be as thorough as a human researcher, well, that introduced its own pretty big challenge, speed. And this just says it all, because the agent has to actively read and process every single document from scratch for every single query. The whole process is extremely slow. It's just not practical for any kind of real-time thing where you need an answer in seconds, not minutes. So that huge performance bottleneck, it led directly to the next evolution of this idea, a hybrid system, one that could combine the raw speed of traditional search with the deep intelligence of an agent. The solution is this really elegant dual-path pipeline. The basic idea is to use a fast, automated pre-filter to drastically cut down the number of documents that the intelligent but slow agent actually has to look at. It's like giving the agent a huge head start. So how does this pre-filter actually work? Well, it uses a few clever tricks. First, it uses that smart chunking and embeddings for fast semantic search. Then it automatically pulls out key metadata, things like dates, names, or financial figures. Finally, it takes all of that info and indexes it in a super fast database like DuckDB. The key here is that this all happens once, upfront, creating a searchable map of your documents before you even ask your first question. This chart shows how it all comes together when you actually ask a question. Your query comes in and immediately gets run through 2 fast filters at the same time, a semantic search on the chunks and a filter on that metadata we just talked about. These two paths very quickly create a short list of potential documents, and only those documents get handed off to the powerful agentic search for the final deep analysis. It really is like a funnel, narrowing down the search space for the agent. So here's the really cool part. This hybrid architecture isn't just one single solution, it's actually a flexible framework. It creates a system with multiple, powerful ways to operate. And check out these modes. You can run it in pure agentic mode if you need a super deep, exhaustive search and speed isn't an issue. Or you can turn on the semantic search pre-filter for a good balance of speed and context. You can use just metadata filtering if your documents are highly structured. Or you can just turn everything on for the absolute best combination of speed and relevance. It means you, the user, get to pick the perfect trade-off for whatever you're trying to do. Now, you might be thinking, a system this sophisticated has got to be expensive to run. But because it's so efficient at narrowing down the search and it uses these highly optimized models like Google's Gemini 3 Flash, the average cost per query is a tiny, tiny fraction of a cent. So it's not just powerful, it's also incredibly cheap to run. And all this brings us to a final, much bigger question. This hybrid agentic model is a seriously powerful design pattern for search. But think about it. If we can successfully teach an AI to read and research like a human, what other complex, multi-step tasks can it learn to do next? That's where this really starts to get exciting.